will see the ma- mass participation factor and mass participation amount. Uh, the time of seismic acceleration, uh, the the total mass of the structure, 90% of total mass of the structure should be participate. Otherwise, due to seismic acceleration, that is will be stability problem, that will be creating a stability problem. So first we have to check whether the mass participation is equals to or above, whether equals to or above the 90%. So then first go to processing, not needed processing. So you go to utilities and output file, and here the participation factor. Double click, and you can see here uh, summation of x direction is uh, greater than 90%, means 95, and also summation of z direction, uh, the mass participation is 95 plus. So uh, the stability of that structure is so high, no problem. And here, one case, if it is if it is less than the 90% in both the direction as x and z, then we have to increase the cutoff mode. Cutoff mode here, uh, I have taken the number of mode. Cutoff mode is 20. If not above the 90% or equals to 90%, the mass participation, then we have to increase the mode, cutoff mode, uh, up to that number uh, at which the mass participation above or equals to 90%. So if mode number is 20 and that is less than 90, then I have to increase the mode number. Uh, Mode number is 20, then I have increased in 25, thereafter 30, 35, up to the number at which the participation factor should be 90%. So keep it in mind, is it is very important, and we have carefully checking that position. And also you have to check the base shear. You can see along z direction the base shear in both the case, base shear in static and base shear for dynamic equal, and that is why the ratio is 1. So you should also check it. And mass participation factor, all the cases 95, 95. So no problem. Now I will uh, describe how to calculate the response spectrum. That is the response spectrum, how it will comes. Then it will, so minimize that and go to loading, uh, load case, and in this case, so click here and edit. In this case we can clearly see, you can also change the code. So now is available in ISO 1893 Part 1 2006. And in this case, I have used this. In this case, I will. This is actually this 1893 2002 CQC. You can use SRS, and here this is the acceleration from acceleration spectrum type acceleration. It is 0.025. How it will come? It will come. The equation is Zi by 2 2r. So let's check Zi by 2r. So Z is 0.24 for the seismic zone 4, and I is importance factor 1, and that means 0.24 divided by 2r. 2 into r. R means the response reduction factor. Response reduction factor, I will take, I have taken 5. So 0.24 by 10, that is 0.024. And this is the scale up to equals the base share according to the base share of static case. So you have to scale up the multiplying the scale up 2.2957. uh, Damping ratio is 5%. 5% damping means the dissipation dissipation of energy. Dissipation of energy. The soil we have taken, I assume that the soil is dissipate the energy 5%, not more than 5%. So this is damping ratio is 5% means 505. So in this case is 5 direction, two direction along x and two direction along z, and one direction is y. So total 5 direction. I have provided the spectrum acceleration. You can check it. So that is the actually discuss about the seismic parameter. And also you mm, check the seismic definition from here. Zone is reduction factor 5, and one is importance factor. Soil, actually soil, subsoil SS is the 2, soil, and ST is 1. Damping ratio also 5%.